Starting back up with test 2 from the College Board site. This is going to be out of the 6 paper tests on their site. Test 2, this is going to be module 2 of the math. If you're looking to skip to the harder problems, they're going to be a little bit further down. They're going to be the ones that I have underlined. So as you come across these ones, you know these are going to be some of the tougher problems. But starting with page 1 here, let's see what we got. We got 55 students in a Spanish club. A sample of the Spanish club students was selected at random of those surveyed. So let me just think here. So we have 55 total. And then we have, maybe you would say like this X that's a sample. And they say of those surveyed, right, 20% said they do intend to enroll. So an important thing to remember here is this, kind of is applicable to all of our sample and total population problems. This is very common. We have a total which might be too hard for us to represent. So what we do is we take a smaller sample, maybe it's like 10 students, and they say out of these 10 students, 20% intend to do this thing. And with a margin of error, we are going to apply this 20% to our total. Okay, very normal process. So how do we do that? Whenever we have a percentage of a total, always change it into decimal form. So it's just going to be 0.2 and then multiply by your total. So times 55. And if I do that in my calculator, I should get A, or 11 here for the students that do intend to enroll in this program. So not too crazy of a problem. For number 2 here, we have Jay walks at a speed of 3 miles per 1 hour. And he runs at a speed of 5 miles per 1 hour. And they tell us some units here. They give us W for hours and R for hours. Okay, so W is going to be the hours that he's walking. R is going to be the hours he is running. But it's cool because these are both hours, right? So let me label that. So those are both hours. And they tell us for a combined total of 14 miles. So 14 is going to be miles in this problem, right? So if I look at A and B, what's going on here, right? I see a W and an R. Well, that's hours and that's hours. But what are the 5 and 3 doing? If I walked for 1 hour, I would travel 3 miles, right? If I ran for an hour, I would travel 5 miles. And 14 is also in miles. So A already checks out that my units all make sense. For my W and R, I plug in hours. The 3 and 5 turn them into hours, and then my 14's also hours. Kind of looking at problems like this can help you with the harder unit problems. We'll go through B and B through D just to make sure that those don't make sense. So again, 14 is in hours or in miles. R and W are going to be in hours, but then they're multiplying by a third and a fifth. So that doesn't make much sense because we're trying to translate this side of the equation into miles. So for every W that's 1, we should get 3 miles. We're getting a third. That doesn't make sense. I look through C and D, 112. Well, that's just going to be irrelevant. 112, maybe they're trying to turn this into hours, and that's how we get the fractions. But all I care about is getting 14 miles, and I get 14 miles by translating my W and R into miles by multiplying them by 3 and 5. So A for this one. I look up at number 3 here, and let's see, we got a graph, we got a line, and maybe they're going to ask us some aspects of it. So we have the relationship between 2 variables, X and Y. We have a line of best fit. Which of the following equations best represents the line? So I'm always just on the lookout for my intercepts, right? It looks like we have an intercept of 0, 3. So I look through my answers. It looks like it's going to be a decimal, but it's definitely not negative, right? So it's going to be either A or B because they both have a positive intercept. And then do we have a positive slope or a negative slope? And it looks like this is going to be a positive slope. So another A for this one. So triple A's. Not too bad. And going to 14, a very interesting graph. Let's see what's going on here. But it's only question 4, so they're probably not going to ask us about the function for this graph. F of x is shown. What is the value of f of 0? So always remember for this form, f of x is how it's usually written, right? So they're replacing the x with 0. So on my graph, I just go to when my x is 0, and then I try to intercept my graph, so it's going to be here. So when my x is 0, I should be getting 3 for my y, right? If I scroll down a little bit here, it looks like it's just going to be D for number 4. So again, not too bad these first couple pages. Really good warm-up problems. I look down below. This is going to be excellent practice with my exponents. So for number 5 here, which expression is equivalent? So again, I see m's times m's, q's and q's. So it's going to be exponent rules. So the first thing I would ask is this first m times m. I mean, I guess the first thing I should acknowledge is we only care about units that match. So I'm going to do m with m. I'm going to do q with q. And I'm going to do z with z. Remember, everything is multiplied. 4 times 5 times 7 is the same thing as 7 times 5 times 4. So when everything's multiplied, I can reorganize it however I want. So I could take the m, this second m here, and I can just move it to the front and multiply my m's. I can move my q's next to each other, move my z's next to each other, and that's how I'm going to do this problem. So m to the 4th times m to the, remember when we have that invisible exponent, it's going to be 1, right? And how do we do this? When we multiply bases, we do what to the exponents? We add them, right? So it's not going to be m to the 4th. You don't multiply exponents. You multiply the bases and add exponents. So already I glanced through my answers. I think that's just a one-off. I think I just can answer B off that. Let's make sure the other ones make sense. Q to the 9, because it's 4 and 5 equals 9 when you add them. And z to the 2nd, z to the 3rd plus z to the 3 minus 1, because I add them, and it's going to be 2. So remember your exponent rules, multiply bases, add exponents. And on the contrary, when I divide bases, I subtract exponents, right? Great problem. And for number 6 here, let's shift this over a little bit. Okay, so number 6, they want the median of the data. Really, the only thing to remember with median here, there's going to be more intermediate and harder median problems we'll talk about later. With these ones where it's just a list, just make sure to do it in order. So what you could do is instead of maybe reordering it, oh, I actually think it is in order. That's very nice of them. A lot of times it's not. I was going to say you could go through the data, cross off your biggest and smallest number, right? So like if I did this, and then next, and finally next, and it looks like it's just going to be 79. But that process also works if they're out of order. Just find your biggest, smallest, until you get your middle number. That's going to be my median. If there's ever 2 numbers in the middle, you add the 2 together and divide by 2, and it gets your true middle, if that makes sense. Number 7 looks like it's just going to be a little bit of algebra. Subtract 40 from both sides, right? So minus 40, and I should get x equals 55 for number 7. Not too bad there. Number 8. So this is going to be an extremely common problem. I'm already going to start pulling it up. When you see these system of equations problems, you don't have to do substitution anymore. You don't have to do elimination anymore. All we need to do now is Desmos. So let's pull Desmos up here. I will kind of shift it to right there, and we will plug both of these in. Equals 15. This way, it can just lead to less human error, right? As long as we can plug our equations in correctly. -2, I look for my intersection, I get 310. So I will minimize this. I will write out my 310. Remember, that's my x, and that's my y. They ask, what is it added together? And it looks like it's just going to be C for this one. You can see how little room for error there is. I plug everything in correctly, get my intersection point, done. And we're going to be using Desmos for a lot more than just these linear equations. You can use them for the quadratics too. Let's jump down to the next page here. So number 9, let's shift this over. Okay, we have a linear equation. We have a negative slope with a, much bigger y-intercept than the slope is. The number of gallons of gasoline that remains from a full gas of tank in a car after driving m miles. Okay, so each, as our graph goes, right, here's my y-axis, here's my x-axis. As the miles I drive increases, the amount of gas I have decreases. That makes sense. According to the model, about how many gallons of gasoline are used to drive each mile. So what do we think there? What are they kind of inferring here from this question? They're only ever going to ask about your slope or your y-intercept. Your y-intercept, you're going to see things like start, initial, beginning. They're saying how many gallons of gas are used each mile. When you hear that kind of rate, each mile, per mile, always be looking towards your slope. Each mile, when this is 1, I get negative 0.05. When it's 2, I get negative 0.10. So for each mile, I'm actually expending 0.05 of gas from my 12.1 start, right? So again, 12.1 would be maybe the amount of gas you started with. 0.05, or rather negative 0.05, is how much gas you're losing per each M, or per each mile you drive. Awesome problem there. Number 10 here. Already, the first thing I notice here is I have an equal sign with 2 fractions. Let me scroll up a little bit. Anytime you have 2 fractions with an equal sign, or a lot of times you'll see like a 1 equals 11x over y, make it into a fraction so it's 2 fractions with an equal sign, right? Cross multiply always, and I get y is equal to 7b times 11x. And then I'm going to glance down below to see exactly what they want me to solve for. They want me to solve for x. So I just get everything else to the other side. I can divide by, well, we can do 7 times 11, right? So let me just simplify that. 77 times b times x. And then I divide everything that's not x. So I want to get x by itself. So divide by 77b. Divide this by 77b. This should cross off. And I see y over 77b, and I think I see that in answer choice C. So pretty decent problem, cross multiplying, algebra, not too bad. Scrolling up, I see another system of equations. I don't even have to read it. I'm going to be pulling up Desmos. Desmos? There it is. Let's go ahead and plug these 2 equations in. Y equals 76. And y equals x to the second minus 5. And I think I'm looking for an intersection point, and I see it. You got to zoom out sometimes. You see my green line here? I see my intersection points now. I see, I'm going to have to write these down while looking at it, negative 976 and 976. Nice and symmetrical. Let's go ahead and minimize Desmos now. What is the possible value of x? Okay, so I see a negative 9. Remember, x, y, x, and y. And they talk about intersecting points. So it has to be one of these 2, negative 9 or positive 9. This is my only option here, right? They're never going to give you both. They're always only going to give you one answer choice. We got B for this one. Desmos is the key. Starting with number 12 again here, I see another system of equations. Not even going to think about it. I'm going to throw this in Desmos. So they want me to plug in y is greater than 14, and also that 4x plus y is less than 18. Okay? So I see a lot going on here, right? So let's just get an idea of like what these inequalities graphed means. So I see over here, this is just going to be the shade purple. This is going to be this inequality here. That's only going to be one of my conditions. Then I see down here, I see this kind of like lightly shaded black area. That's going to be just this condition or this inequality being met. This overlap, where you see purple and black overlapping, is going to be my solution area. If a point fits in there, that is a point that is a solution to this equation. I'm going to show you the problem real quick. They say the point x53. So if I kind of shift back to my graph, I can make points. If I look at my answer choices a little bit, you know, for example, just these 2 to kind of test it. What I can do here is I can plug in a point. For my x, I would do negative 9. And for my y, it would be 53. And what's cool is it's going to show me this point on my graph. And all I'm looking for is, does it fit my solution area? Does it fit where there's purple and black? And it does. You can see the red dot there. The first one, A for this one, already fits. Super easy. Plug in my 2 equations. Plug in all my answer choices. But since it's just like typing, I don't have to do any equations or any math. you could get this one done super fast. So not too bad for number 12. Let's minimize that. A for 12. Scrolling down on this next page, this will probably be the last page here. Break it up into 2 or 3 parts. So number 13, we have 300 seeds. Let me just hide Desmos real quick. Okay, we got 300 seeds that were planted and 80% sprouted. How many seeds sprouted? So there's only 2 ways to do this problem. 300 times the 0.8 to get how many sprouted, or times 0.2 to find out how many like didn't sprout, right? So they want how many sprouted, so I just do 300 times 0.8, and I should get 240 for 13, and that is correct. Not bad. Scroll down a little bit for 14. We have f of x is equal to 4x. For what value of x? So what value can I plug in here that I also plug in there to get 8? Well, when x is equal to 2, 4 times 2 is equal to 8. So really not too bad for number 14. That one's kind of a freebie. So it's going to be when my x is equal to 2. I scroll down to number 15 here. Finally, an underlined one. This one's going to be decent. Which expression is equivalent to this, right? Okay. So what could we try to do here with this problem? We always want to try to look for shortcuts. Whenever I see these x's, x squareds, parentheses, almost call them kind of functions, I always want to think, can I factor anything? Is there anything I can simplify? First, I start with my numerator. Is there anything I can factor up here? And there is. I can literally factor out x minus 7. And I think it's going to make more sense when you see it written. So if I factor out x minus 7, think about what was multiplied by x minus 7. It's going to be this 8x, and it's going to be minus 3. So if I redistributed this, it would be x minus 7 times 8x. That's what you have here. And then it would be x minus 7 times negative 3, which is exactly what you have here. Negative 3 times x minus 7. So this kind of bigger form factoring is going to really help you with these problems. So that's going to be my new numerator factored. And then divided by, can I factor that bottom? I can. I can take a 2 out. If I take a 2 out of the bottom, I should be left with x minus 7. And then I can cancel out numerator and denominator, the x minus 7s. And I should be left with 8x minus 3 divided by 2, or answer choice B for 15. Really good problem. I have it underlined because it's important to remember those different forms of factoring. Of course, you could multiply everything, then factor. This is just going to make it a lot faster, a lot more optimal of getting our answer here. So we'll try just this right-hand side here. Let's jump up to number 16. What's going on in 16 here? Let's see. So we have line P is defined by this. Okay? That's line P. Line R is perpendicular to P. So the first thing I want to do when I see perpendicular is I need to translate this into y-intercept form. So 2y, or slope-intercept form, is equal to negative 18x. So I just subtracted the 18x to the other side. Plus 9, because the 9 didn't move. And then I want to divide by 2. Divide by 2, and divide by 2. So my new equation should be y is equal to negative 9x plus 4.5. Right? Not too bad. So that would be line P, right? They want to know line R, which is perpendicular. Perpendicular is going to be negative reciprocal. So I know that line R would equal to 1/9 x and then plus b. They don't give us enough information that I would know what the y-intercept is going to be, but I do know that this turns into that because, again, reciprocal, so I flip it. So it's technically negative 9 over 1. So I flip it to 1/9, and then I change my sign. So it was negative, becomes positive. Looks like I'm looking at C for number 16 here. Excellent problem. And then probably our finale for this little part here, number 17. Let's see what's going on here. So super important. These are going to be our exponential functions. This is going to be our principal or our starting amount. Think y-intercept, right? When this is 0, this becomes 1. Anything raised to the 0 is 1 times 8,000. That is going to be my y-intercept. So I can write that y-intercept. The number in the parentheses always tells me if I'm increasing or decreasing. If it's 1, oh, I got to scroll up a little bit. If this is ever 1, there's no change. If it's greater than 1, if it's like 1.05, this is how much I'm increasing. And then whatever amount I'm less than 1. So think about that. That is 1 minus 0.35. This is how much I'm losing. I'm losing 35% of my start, right? So let's look through our answers to see. Actually, let's just get the context a little bit to see what they're talking about. So this is the number of coupons a company sent. So it's decreasing. We're losing 35%. Each year, T is going to be number of years. Each year, we're losing 35% of the coupons we're sending to people. So they want to know the best interpretation of the y-intercept. We already know that's going to be our start. 8,000 is going to be what we started with. If the context is coupons, it's going to be how many coupons we started with. The minimum number of coupons the company sent to their customers was 1,428 during the 5 years. So we don't care about during the 5 years. The y-intercept is going to be what we start with. We're looking for an answer that describes the start. The minimum estimated number of coupons that was sent during the 5 years, that's not our start. I scroll down a little bit for D. The estimated number of coupons sent to their customers at the end of 1998 was 1,428. Our y-intercept's 8,000. So like my answer has to talk about the 8,000, right? D, the estimated number of coupons the company sent to their customers at the end of 1998. When does our graph start? The years since 1998. So my first year is 1998, and D is talking about 8,000 was our start, or that first year, 1998. So it's going to be D for 17 here. Excellent couple set of problems. We got through, I think, 2 or 3 pages there. We will jump back next time with part 2 and probably just finish this module.